All right, let's warm up our solvers for the day. So this, for reference, is 2.1, number 3. The thing I'm more interested in maybe is what solver am I warming up? Like, what is this thing? What kind of equation is this guy?
Linear homogeneous.
This is,
linear. First order linear.
it's linear.
First order, yeah.
What's making it linear?
The fact that the y prime is this guy.
Yeah, the fact that you've got a y prime and a regular y, and they're not multiplied together. They are, in fact, added together, and there are some coefficients in x, right? So this thing is a polynomial in derivatives of y.
It being equal to 0 contributes to that too, right?
Okay, so the equaling 0 makes it the
Trivial.
homogeneous part, which is going to make the solution I get the solution to the complementary equation, or the, as I would say, the homogeneous solution. You guys see that? We should stay away from, what was the other word mentioned that I should stay away from?
Trivial solution.
Yeah, there is a trivial solution to this one, right? Which I could note over here. I could be like, hey, dude, why is 0 works?
Yeah.
Sweet. Okay, so I have a linear thing. It's homogeneous. It's homogeneous because of the 0. What order is this?
First.
This is a first order, linear, homogeneous, differential equation. Right? It's good if we can start putting those words in, because when you look at a new differential equation, oftentimes if you just say what it is, your brain will kick to the right spot. Right? Like there's going to be a technique for solving each of these, and some of them are slightly different than others. So what you're going to do is you're going to get like, okay, if it's this, then my brain has to click to this page, and then I start the technique on that page in my brain. Cool? All right, so for this one, how do I start solving first order linear homogeneous things? Yeah, I could try separation of variables. That'll work sometimes. Let's try it on this one. It'll be fun. So if I want to separate the variables here, how do I do that? Okay, so I'll subtract log of x times y to the other side. So I got xy prime is minus natural log of x, y.
Rewrite y prime as dy dx.
Okay, so I got x dy dx is minus the log of x, y.
Your x's and y's on the same side.
Okay, you got to get the x is all to one side and the y is all to the other.
So divide that like x, y.
So I would multiply through by 1 over xy. Yeah, that seems legit. Oh god. New marker. Okay, so I'm going to multiply through by 1 over xy. So I'm going to get dy dx.
Times 1 over y.
I got a 1 over y there, right? And that's going to equal
Negative log of x over x.
negative log of x over x. Cool. Now what?
Dx.
Move the dx to the other side, so multiply through by 1 over dx. Wait, no, by dx over 1. Got it. Okay, so I got 1 over y dy is minus the natural log of x over x dx.
Integrate both ends.
Okay.
And you know your left side.
Slap a squiggle on both sides, and you can notice that the left side is the,
Absolute value.
yeah.
That's the one.
Yeah, I'm going to trust that you guys know that we can leave off the absolute value there, because I'm going to get that into the constant later at the end. That's cool? So from now on, you can leave those out of your separation of variables because you know how that works. It'll make your life a little easier. So I got natural log of y equals, what do I have on the other side?
Negative.
I think I got negative the integral of log of x over x dx.
Is it negative 1/2 log of x squared? Or is that not? Right. Okay, then
Log of x is a function, right?
or natural log of x over x squared.
You've got to do these substitutions.
Yeah, you got to do u substitution.
So you can't just make like integral of natural log of x times integral of 1 over x?
No, nice try.
You let u equal
Why doesn't that work again?
Yeah.
It seems
Because
like it should.
integrals are linear operators, meaning I could break them up over addition, but you can't break them up over multiplication.
Okay.
In the same way that derivatives break up over addition nicely, but when you're differentiating a product, you can't just take the product of the derivatives. You need the product rule, right? Same thing. So to back out of a product in integral land, you would like to have some kind of product rule thing, right?
What is the parts, isn't it?
Well, you don't really have a product rule, right? You could like try parts or you can try u substitution. Like sometimes one, sometimes the other. In this case, I want u sub. So you're going to let u be log of x, and then du is 1 over x dx. And then what do you do with this? Plug those bits in. Okay, so I got natural log of y is minus the integral of, let's see, that guy's a u, and then, how do you guys do u substitutions? I didn't teach you guys calculus, so do you have weird,
Just use square root of 2.
you do this thing where you circle the du?
No.
Let me recommend that you do that so you don't have weird stuff left over. So that stuff turns into a du, right? And then the rest of it is a u. So I got the integral of u du. Cool? Okay, now what? What's the integral of u du?
1/2 u squared.
1/2 u squared. So you got natural log of y is minus 1/2 u squared. Plus constant. And furthermore, yeah, and furthermore, u was something, right? What was u?
Natural log of x.
Natural log of x. Why am I putting that back in?
There's nothing like in this problem. It's something we made.
Yeah, good. Because they ask you a problem about x's and y's, and you all of a sudden have u's in your answer, you nut. Right? You got to answer the question you were asked. You can't just answer any old question. Okay, so now I'm here. Now what do I do? Ermagerd. Okay, slap an E on everything. Wait, so hang on. So this whole business, like all those steps were,
Well, talk to we didn't do that.
it's like the first week of Calc 2. Okay, but it is actually Calc 2. That's what. All right, so I got to here, and then what do I need to do? Okay, I need to get y by itself, so I do e to the stuff to both sides. So I got y is e to the minus 1/2 natural log of x quantity squared. Oops. Why am I? What did I just screw up?
Should have been plus for the e. Not
Yeah,
for
the
the exponent.
plus should be in the exponent, right?
Yeah.
So plus c in the exponent makes
E to the c.
arbitrary constant up front. You guys good with this? Okay. Great. Video is perfect. Okay, questions, Steels?
Since we have a formula for this, could we just find out?
Yeah. So you, this whole business, right, from from right here, passing all through this junk to here, was what method?
The negative integral, the negative integral variation.
Separation variable.
No, not what could I have done, but what did I do?
You did separation.
Yeah, I did separation of variables. Is separation of variables the only method I could have used? No. I could have said, okay, I could take this whole thing, write it in the usual form, right? And the usual form is that, maybe let me dump some of this stuff. So what's the usual form I'm shooting for?
Y prime plus p of x, y.
Y prime plus p of x, y equals 0. Okay, so what's p in that case?
Natural log of x over x.
Natural log of x over x. And so if it's written in this form, you know the solution should be y of x is e to the minus integral of p of x dx. Yeah, and you do need a constant in front. Thank you. Cool.
Joe, okay, I got lost in here.
Okay.
How did we go from a C to an A?
Oh, because that business is, let me put it right here. So my y was more honestly, was y of x is e to the minus 1/2 log of x quantity squared plus a constant. And then I used an exponent rule to say, well, that's e to this
C.
crap as a function of x times e to the c.
Okay.
And then I rewrote this arbitrary constant as a. And I also ate the plus or minus that would have had to be.
Okay, cool.
You guys all good with that? And either way, you'll get the same thing, right? So you can either, for this problem, you could either separate variables and go through all this rigmarole, or you could remember how the solution's supposed to look and then do a U substitution to figure it out.
And do you care which one we do on homework? Or
Not at all.
for this test?
No. I would like you to have facility with both of those techniques. I would also like you to not waste your entire existence. Okay, so I want you to know how to separate variables because separation of variables is a little more general than solving this thing. This thing you can always do by separation of variables. And I don't really care whether if you choose to experience separation of variables more often, have at it. If you want to just memorize how the solution looks, that's also fine. What's up?
If you have y prime minus p of x y equals 0, is it just y of x equals a to the e, or a times e to the positive integral of p of
Yeah.
dx dx?
Yeah, so if you have a plus a minus p of x in here, that'll put another minus in there, and you can pull the minus out. Yeah. Cool. Questions, Steels? No? Cool.